Good morning, concept students. Today is our last day of lecture notes, so I'm going to give you some examples on our third method to solve a system of equations called elimination. So the first most popular method is substitution, which we learned in our last class meeting. Now we're going to go through elimination, the next most popular method for solving a system. Graphing doesn't always work, but that is our third option, and that was the first option that we looked at. So elimination, this is a combination of day 4 and day 5 notes. So you'll notice that when I posted the notes, that's what you'll see in those. All right, so let's go through our examples. So elimination, again, a third way to solve a system of 2 or more equations. When we eliminate, you're trying to get rid of or eliminate one of our 2 variables, either the x's or the y's. Then you solve for one variable, plug it back in using substitution, which is why we had to learn that first, and then go ahead and solve for the second variable. So let's start with our first example. X minus y equals 14. X plus y equals 20. Now, we are adding vertically when we do this. So you want to have your variables lined up so that the x's and the y's are all lined up vertically. Because when I add, my goal is to cancel one of the variables out. Well, if I add 1x plus 1x, I get 2x. If I have negative y and positive y, those cancel out. If I add 14 plus 20, I get 34. So I've created a new equation in terms of only x's. I divide by 2, so I get x equals 17. And that is the first part of my answer. It is my x coordinate for my solution. Now we're going to do the next part, which is to substitute. We're going to take this x equals 17, and we're going to plug it back into either one of our 2 equations. It doesn't matter which one. I like positive equations, so I'm going to plug it in here. In place of x, I'm going to write 17 plus y equals 20. We're going to subtract 17 so that we get y equals 3. All right, so now we have our solution, 17 for x, 3 for y. It is an ordered pair just like we got with substitution or with graphing. Okay, so it's a one solution problem. All right, so that's our first example. Let's try another one. Again, we're trying to get rid of a variable by adding vertically, eliminating it vertically. Okay, so here we go. Next one, number 2. We have negative 4m plus 2n equals 6. And again, it doesn't matter whether it's x or y, whatever it is, line them up. The next part is negative 4m, this is my second equation, plus n equals 8. Now, this equation is different, or this system is different than the previous system. I don't have opposite signs for one of my variables. These are both negative, they're not opposites, and these are both positive, they're not opposites. Now, you want to focus on the variable that has the same number, and you want one of them to be positive and one of them to be negative. Okay, so we're going to focus on the m's. They're both 4s. They're both negative 4s, in fact. So I need to make this bottom 4 a positive. Well, how do I do that? I change the sign of every single term. So this is going to become a positive 4. This then is going to become a negative n, and this is going to become a negative 8. All I did was change the sign of every single term, and I'm ready to add vertically. Add. Negative 4m and positive 4m eliminate. They go away. 2n plus negative 1n is 1n, or just n. You can just write an n if you want, okay? And then we add the constants. 6 plus negative 8 is negative 2. So now I have my first variable solved for. Well, what do I do with that then? Plug it back into one of your 2 equations. So this time, let's go with the top equation. In place of n, I'm going to put my negative 2. Negative 4m plus 2 times negative 2 in place of the n equals 6. And we're going to simplify. Negative 4m, this becomes a negative 4 equals 6. 2 more steps, add the 4, cancel that out. Negative 4m comes down, equals 10, and we divide by negative 4. Well, that's not a very nice number. It's a fraction. You can either leave it as 10 over negative 4, or you can reduce your fraction. M equals, if we divide both of those by 2, 5 over negative 2. And now I have my solution. I have my m value and my n value. So my point is 5 over negative 2, which is negative 2 halves if you like decimals, comma, negative 2. Now, some of you might say, well, why did you put it in that order? I just went alphabetically, right? M and then n in the alphabet. So just like X and Y in the alphabet, you always just go alphabetically with your coordinates. All right. Now, next one. Sometimes we don't have very nice numbers. We have to manipulate our equations a little bit more than just changing signs. So what does that look like? Let's show you. Okay, so for example, in number 3, we've got, actually, you know what? I think I'm going to go ahead and show you when it's, what happens when we have different solutions. So let's do this one first. 3x plus 4y equals 6. And let's see, negative 3x. Oh no, a positive 3x. Again, plus 4y equals 2. All right, got my example correct. Now, you'll notice both the 3x's and the 4x's are the same exact numbers, but they have to have opposite signs. At least one of them does. So let's pick an equation and change all the signs. Change, change, change. Okay, well, once we do that, we're ready to add vertically. Those cancel out, so I'm left with nothing for my variables. So a 0 equals, if we add, we get a 4. Does 0 equal 4? No. So this is not true, it's false. So my answer is no solution. Okay? Now, we also have an option where it's infinitely many. So let me show you right below it what that looks like. So this time I have 5x minus y equals 4. And then negative 5x plus y equals negative 4. Now notice, all of my signs are opposites. So when we add, this cancels, this cancels, this cancels. We're going to get 0 equals 0. Is that true? Absolutely. When something equals itself, it is true. So our solution is infinitely many solutions, or IMS. Those are the 2 unique situations, okay? All right, now, like I said, those are pretty easy to cancel out the variables, but they don't always happen that easily. So let's look at next. Our next 2 equations are slightly different. Okay, number 5. 2x plus y equals 3, and negative 4x minus 4y equals negative 8. Now, some of you might say, well, we have opposite signs for both the x's and the y's, but we don't have the same number in front of the x's or the y's. But I can turn my x's and my y's into that same number, either x's or y's. You don't want to necessarily do both. So let's see. I could turn my 2x into a positive 4x, so that would cancel. Or over here, I could turn my 1y into a positive 4y, so that would cancel as well. Okay, well, let's say we decide to deal with the x's. We like x's. Let's deal with the x's. How do I turn 2x into 4x? I multiply by 2. Whatever you do to one term, you do to all the terms. Every term gets multiplied by 2. So I'm going to rewrite this entire equation right below here. Okay? So now I have 4x plus 2y equals 6. My second equation does not change. I'm just rewriting it so it's clearly lined up. And now we add vertically. Boom. Cancels out the x's. It does not cancel out the y's. 2y minus 4y is negative 2y. 6 plus negative 8 is negative 2. Divide to get that y by itself. So we get y equals 1. But I'm not done yet. I still have to solve for x. Okay. So go back up to one of your two original equations and plug in your y value. Let's go with our top equation. So I'm taking this, it's going all the way back up in here. Okay, so 2x plus 1 in place of y equals 3. So 2x plus 1 equals 3. Subtract the 1. 2x equals 2. Divide by 2. X equals 1. And there we go. We've solved for y. We plugged it back in. We solved for x. And my solution, again, is a point. It is the point 1, 1. That is my answer. Okay? It's not no solution. It's not infinitely many. We actually got a point. Okay, let's try another one. Okay. So those can be tricky because you have to figure out what variable you can cancel out. And in order to do that, you're going to have to multiply either one or both equations, typically one equation, by a number. Okay, so here's my next example. Let's do, let's see, I want to make sure we get one that we can eliminate nicely. Oh, perfect, I got one. Okay, here we go. Number 6, okay? 2x minus 3y equals 7. Now, this one's slightly different. If you printed off the notes, I decided to go with a different one. So just scratch off the one I had for number 6 and copy this one down. Okay. And then negative 4x plus 6y equals 14. Okay, so let's go through this one. All right, when we look at this, I have opposite signs for both my x's and my y's, but not the same number. So again, let's deal with x's because we like x's. If I want to cancel, I have to turn the top x into a 4, meaning multiply by 2. Okay, so we're going to rewrite that top equation. Okay, so we get 4x minus 6y equals 14. The bottom equation does not change. Okay, and we're ready to add. Ooh, cancel. And these cancel, so that's a 0, and we can add to get 28. What would my solution be? Is that true? No, it's false. So it is no solution. Very good, but we had to multiply first in order to figure that out. All right, so that is our elimination. Let me see, is there any other elimination problem that I would like to do with you? I think that should be pretty good, but elimination can be tough, guys. So if you're struggling with this, please make sure you let me know. This is our last method to solve a system of equations, okay? And there's a couple practice problems for you to do on the worksheet, doing elimination. Only do the ones that I told you to. The other ones get a little bit more tricky. So good luck with that. Submit your work so you get some points. And then on Thursday, I'm going to post a video of me going through the exam review in addition to the exam review packet itself. I will go over the questions I expect you to know how to do, similar to the ones that you will see on your exam, which is going to be the following week, Monday, during your class period. So 4th hour exam will be first, then we'll have 5th hour exam, then we'll have our, I think it's 4th hour exam first. Yeah, then we'll have our 6th hour exam. Yep. So 4th, 5th, 6th, that will be on Monday. So 4th hour is first and 6th hour will be last on Monday. So hang in there, guys. We're almost done. About a week. Okay, a little over a week. So we can do it. All right. Thanks so much. Have a great day.